Welcome to the session on trigonometric functions, graphs of sec, cosec and cot. The objectives for this session are to understand graphs of secant, cosecant and tangent and their domain and range. Recall the reciprocal trigonometric functions. Sec equals 1 over cos, cosec equals 1 over sine, and cot equals 1 over tan. We're going to use the graphs of y equals cos, sine and tan to sketch the graphs of their reciprocal functions. Let's look at y equals sec theta first in the interval minus 180 degrees less than or equal to theta less than or equal to 180 degrees. Of course, sec is defined as 1 over cos, so we begin by sketching the graph of 1 over cos. Here we have the graph y equals cos theta in the given interval. We're going to make some observations. When x equals 0 degrees, we have that cos 0 degrees equals 1. Using our formula, we have that sec 0 is therefore also equal to 1. When x equals 180 degrees, we have cos 180 degrees equals minus 1. And again, using our formula, we have sec 180 degrees equals minus 1. Similarly, for cos 180 degrees, we have that this is equal to minus 1, and therefore sec 180 degrees is also equal to minus 1. When x equals 90 degrees, we have that cos 90 degrees equals 0, which implies that sec 90 degrees is undefined, as sec is equal to 1 over cos. So on our graph of y equals sec theta, we will have an asymptote here, as shown. Similarly, for x equals minus 90 degrees, we have that sec minus 90 degrees will be undefined. So we will have an asymptote here as well. Now as theta approaches 90 degrees from the left, cos theta is positive, but close to 0. So sec theta is positive and increasingly large. Similarly, as theta approaches 90 degrees from the right, cos theta is negative but close to 0. So sec theta is negative and increasingly large and negative. Therefore, our graph of y equals sec theta will look something like this in blue. We're now going to take a look at some important features of the graph of y equals secx for x in the real numbers. So here's a sketch of y equals secx. It has symmetry in the y-axis. Its period is 360 degrees or 2 pi radians. So notice the pattern repeats every 360 degrees. Here, 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 and so on. It has vertical asymptotes at all x with cosec equal to 0, as denoted here. The domain of y equals secx is x in the real numbers, with x not equal to 90 degrees, 270 degrees, 450 degrees, and so on. In other words, all the odd multiples of 90 degrees. In radians, x will not be equal to pi over 2, 3 pi over 2, 5 pi over 2, and so on. In other words, the odd multiples of pi over 2. And the range of secx is y less than or equal to minus 1 or y greater than or equal to 1, as shown. We can write the domain of y equals secx for x not equal to pi by 2, 3 pi by 2, and so on, as x in the real numbers with x not equal to 2n plus 1 times pi all over 2 for n in the integers. Let's now take a look at the graph of y equals cosec x. This is a shift of the graph of secx and looks something like this. It also has a period of 360 degrees or 2 pi radians, since it repeats every 360 degrees. It has vertical asymptotes at all x with sin x equal to 0, as shown here. The domain of y equals cosec x is x in the real numbers with x not equal to 0, 180 degrees, 360 degrees, in other words, all multiples of 180 degrees. Or, in radians, x is not equal to 0, pi, 2 pi, in other words, all multiples of pi. And its range is y less than or equal to minus 1 or y greater than or equal to 1. The domain of y equals cosec x can also be written as x in the real numbers with x not equal to n pi, where n is a member of the integers. We now examine the graph of y equals cotx for x in the real numbers. This looks something like this. It has a period of 180 degrees or pi radians, so the pattern repeats every 180 degrees, as shown. It has vertical asymptotes at all x with tan x equal to 0, as shown here. Its domain is x in the real numbers with x not equal to 0 degrees, 180 degrees, 360 degrees, and so on, in other words, all multiples of 180 degrees, or x not equal to 0, pi, 2 pi, in other words, multiples of pi. And its range is y in the real numbers. In notation, the domain of y equals cotx can be written as x in the real numbers with x not equal to n times pi, where n is an integer. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We're required to sketch the graph of y equals 2 sec x for x in the interval minus pi to 2 pi. So let's solve this. Here's a sketch of y equals 2 times sec x. Notice that this is a stretch of y equals sec x. Now sketch y equals 0.01x on the same axes. This will look something like this. And finally, write down the number of solutions to the equation 2 sec x minus 0.01x equals 0 in the same interval. Now this equation here can be rewritten as 2 sec x equals 0.01 times x. So essentially we're looking for how many solutions there are in this graph. So where does 2 sec x intersect with 0.01 times x? there is actually only one point where it intersects in this interval, and it's highlighted by the red dot, as shown. So therefore, there is one solution in the range minus pi to 2 pi. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's take a look at this example. We're required to sketch y equals cosec 3 theta minus 1 in the interval minus 180 degrees less than or equal to theta less than or equal to 180 degrees. Cosec x equals 1 over sin x. So we're going to focus on this particular graph. Here's a sketch of y equals cosec theta. However, we're required to sketch y equals cosec 3 theta minus 1. So let's do this step by step. Cosec 3 theta will look something like this. And y equals cosec 3 theta minus 1 is a shift in the y direction as shown in green. So it will look something like this. This brings us to the end of this session. If you have understood its contents, you should be able to understand graphs of secant, cosecant, and tangent, and their domain and range. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.